Welcome everyone. Today we are solving problem number 7.48 from Sadiku book. So the problem says find VT and IT, and the circuit is given something like that. The thing we need to be focusing on in this is the singularity function is given, or unit step function is given as u minus t. As we know, unit step function that ut equals to 0 for what? T is less than 0, and 1 for what? 1 for t is greater than 0, right? But if the singularity function is in u minus t form, it will be 0 for what? Minus t is less than 0, and 1 minus t is greater than 0, right? Just replace t with minus t. Okay, so as we know from the rules, if we multiply negative both sides, the sign will be changed. So for 0 it will be t is greater than 0, and for 1 it will be t is less than 0, right? Okay, so it is completely opposite of this. So ut and u minus t is completely mirror image of each other. So here the current source is given in u minus t form. So if the function or for t is less than 0, for t is less than 0, what is the value? For t is less than 0, the value is 1. So u minus t will be what? U minus t will be 1, right? U minus t will be 1, and because for t is less than 0, the function will be in 1 or steady state mode, we can replace the capacitor as open circuit. So if both terminals are replaced with open circuit, is there any current flow in this 20 ohm resistance? Obviously not. There will be no current flow in 20 ohm resistance. So whole current, or the 1 ampere current, will be go this way and complete its pathway in this loop, right? The 1 ampere current will go through 10 ohm and back in the current source. So it is a loop here. So there will be no current flow in 20 ohm resistance, and it will be replaced as open circuit. So here the voltage V0, we can calculate it as V0. The V0 is as equals to the voltage drop due to 10 ohm resistance, right? The voltage across 10 ohm resistance is equals to V0 or V, right? Because of there is no current flow in 20 ohm resistance, the voltage across 10 ohm resistance are equals to the voltage across the capacitor, right? Okay, so here V0 equals to what? V0 equals to the whole current is passing through the 10 ohm resistance, so it will be 10 into 1, which is 10 ohm, right? Okay, now calculate for t is greater than 0. Okay, for t is greater than 0, what will be the value? It will be 0, so ut will be 0. So if the current source is 0, what will be the voltage drop across the capacitor? Obviously it will be also 0, because there are no current flowing in the whole circuit, so the voltage will be also 0. So here V infinity will be 0, u minus t will be 0, and I will be also 0. And if we calculate the tau, what will be the tau? Tau will be RTH across this capacitor, right? So RTH across this capacitor are what? 20 and 10 are in series, so it will be 30, right? Okay, so if 30 into C, what is the value of C? So it will be 0.1, so it is 3 seconds, right? It will be 3 seconds. So if we wanna calculate the voltage equation, it will be dVt, so V infinity plus V0 minus V infinity e to the power minus t by tau. Okay, what is the value of V infinity? It will be 0, so we can just simply write it as 10. Wait a second. What is the value of V infinity? It will be 0. It will be also 0. So what is the value of V0? The value of V0 is equals to 10. So 10 e to the power minus t by, what is the value of tau? Tau equals to 3, right? The value of t equals to tau. So it is the answer of Vt. Now they wanted us to calculate It as well. So for It, we know for capacitor the current is C dV by dt, right? C dV by dt. So here what is the capacitance? Capacitance equals to 0.1. So capacitance equals to 0.1. So we implement this, and d by dt of 10 e to the power minus t by 3, right? So it will be 0.1 into 10 into minus 1 by 3 e to the power minus t by 3. So this is the answer. You can calculate this out. This ampere answer. These both are the answers from this. Let's jump into 7.49. Alright, problem number 7.49. The problem says there are two diagrams are given. One is in functional mode and one is in circuit. If the waveform applied to the circuit, it means this waveform is applied to the circuit, then find Vt when V0 0 equals to 0. Alright, so here we have three terms. One is for 0, negative infinity to t to 0, minus 0 to t to 1, and t is greater than 1. Three limits will be here. So because the V0 0 equals to 0, it will be ultimately 0, so we don't need to consider this out. So we have two ranges right now. So for this range 0 to t to 1, let's solve this out. For 0 to t to 1, for 0 to t to 1, for 0, it is the 0, basically 0. For 0 to t to 1, what is the value of current? Obviously it is constant, so it will be 2 ampere. So Is will be 2 ampere. Right. So if the Is equals to 2 ampere, it does mean that the circuit is in steady mode. Right. It is in steady state mode. So if the circuit is in steady state mode, the capacitor, we can replace the capacitor as open circuit. Right. If the capacitor is as open circuit, replaced with open circuit, then what will be the current through the 6 ohm? Obviously it will be 0. Right. Because it is open circuit, there will be no current flow in the 6 ohm resistance. So the voltage across the capacitor will be as equals to the voltage across the 4 ohm resistance. Right. The voltage across the capacitor will be as equals to the voltage across 4 ohm resistance. Right. So the voltage across the 4 ohm resistance will be as equals to the voltage of capacitor. So it will be V0 equals to what? V0 equals to Is will go through this, and the whole current will pass through this 4 ohm resistance. So the I0 equals to 4 Is equals to 4 into 2 equals to 8 volt. Right. The V0 equals to 8 volt. Now we have to calculate tau. What will be the value of tau? Tau equals to RTH into C. So RTH equals to what? 6 and 4 are in series. So it will be 4 plus 6 into C. What is the value of C? Equals to 0.5. So 0.5. So 10 into 0.5 equals to what? 0.5 actually. So it will be 5 second. Right? Okay. So if we want to calculate the Vt equals to V infinity. Okay. Hold on a second. What will be the value of V infinity? The value of V infinity will be, as we know, value will be V infinity for 0. There will be no current flow in this circuit. One second. There is a mistake on mentioning this out. It will be V infinity. Right. Because we have already given the value of V0. Right. So V0 equals V0 0 for this range is also already given, which is V0 equals to 0. The value for 0 to t to 1 limit, it will be V infinity as 8 volt. So if we want to calculate this voltage as V infinity plus V0 minus V infinity e to the power minus t divided by tau equals to, what is the value of V infinity? It will be 8 plus, what is the value of V in 0? It is already given. So we have mistaken earlier. So it will be already 0. So it will be 0. 0 minus 8, it will be minus 8, right? 8 minus 8 e to the power minus t by, what is the value of tau? Tau is equals to 5 second. So tau, it is the value of Vt. So if we now jump into this range, for this range, what will be the value of infinity? Let's just decide calmly. For this range, the value of V0 will be as equals to the value of V1, because the initial voltage for t is greater than 1 is equals to initial voltage for this range, right? So for V of 1 will be what? 8 minus 8 e to the power minus 1 by 5, right? So the value will be 8 minus 8 e to the power minus 1, so it will be 1.45. And for this range, for this range t is greater than 1, what is the value of current? For this range, the value of current will be 0, right? This value is 0. So for this range, the V infinity will be 0. V infinity will be 0. Okay. So let's just write this out. Vt equals to what? Vt goes to, and tau remains same, tau remains 5, tau remains same, so tau equals to 5. So the for this remains V infinity plus V0. So what is the value of V0 now? It is the value as equals to V1, right? For this range, the V0 will be initial voltage for this range, so it will be V1 minus V infinity e to the power minus t by tau. Already tau is given, so we don't need to write it out. So it will be 1.45 as V infinity equals to 0, this also equals to 0, so it will be 1.45 e to the power minus t by 5, right? 1.45 t by 5. But there's a catch, we can't write this as t because we are calculating this for t is greater than 1 range. T is greater than 1 range. For this range, we have to replace this as 1.45 e to the power minus t minus 1 divided by 5, right? This is the voltage answer. So this will be the answer for 7.49 problem. So I hope you guys enjoyed the video. Thank you very much.